Hola, buenos días. Estamos a sala llena para hacer un viernes.
Good morning. We have a full room Friday morning, so please come closer. We will now begin with the Friday morning block of LACNOG. We have most interesting presentations for today. We're going to have lightning talks. So please join us, and after that we'll have the closing ceremony by LACNOG's chair. So the first presentation today is by Mateus Leal, who will be online, specialized in telecommunications, cybersecurity, and architecture design. He will be making a presentation on SD-WAN as a service, the new era of on-demand lines. So, Mateus. So we'll start with the presentation. You have 20 minutes, and I'll be checking the time. Welcome, Mateus. Good morning, everyone. Before starting, I'd like to thank all those of you who are present on Friday morning. I imagine you have taken advantage of this event, of the contents and the ideas. I think it is wonderful how LACNIC manages to organize these most interesting events. I'd sincerely like to thank the LACNIC team for giving me the opportunity to join you today and speak about this topic. Of course, now I'll be speaking about SD-WAN as a service, a new era in the on-demand networks. To set the context on how this has affected the market, I can say that we now see different ways of providing services such as these, in addition to a new model to provide connectivity to the customers. The objective of my presentation is to share this shift in paradigm, in addition to see how we can do this with our providers, so that you as professionals and as enterprises can make the most of this topic. For those of you who haven't met me, I am Mateus. I'm a telecom engineer specialized in network security. And I'd like to introduce myself as a content producer. I have a YouTube channel where I share tutorials and practical knowledge. So those who are interested, you can check my YouTube channel to learn more. That is also my LinkedIn address and my email in the event if you might wish to contact me directly. Let me now tell you about the WAN timeline. Let's time travel regarding WAN. And this is also so that you can understand where all this began and where we're heading in this regard. So the history began back in 1965 with Lawrence Roberts. Many consider Lawrence Roberts one of the fathers of the Internet at that time. He worked on a joint paper establishing the first WAN connection in history. A bit later, around 1989, the World came up, which was one of the first internet providers in the United States, commercially speaking. I mentioned this because this was a key point. Internet stopped being something related solely to universities and now became something that became part of people's everyday lives. Internet didn't stop to evolve, and now we're in 1993, where the frame relay networks were created with RFC 1490. This was then followed by MPLS. With MPLS, then this is something that our providers started to use in order to have that type of connectivity which we provide to customers. So following the MPLS, which became the market standard, particularly for corporate services, we then had the possibility of require providers to deliver better services to our customers. Over time, this evolved. So let us now see what this change led to. In order to learn about the change in the scenarios, I have here an example of a case study of a customer. We have an event. This is a smaller sample which can then be expanded. You can include many more data centers. You can include many more end customers. The connectivity of these nodes, as you can see between the providers, were done by ISP1 or ISP2. The role of the provider in this case was to offer circuits such as MPLS, and the rest of the communication took place over here. This is how we provided internet to our customers. So at the time, we participated with the construction of the customer's infrastructure. In the mindset of our customers, we could not replace that structure. So the entire responsibility expected from the customer very often was somehow uncomfortable for them, because this required that the clients should be more specialized on these types of networks, in more robust networks, which then led to higher operational costs and a complexity of the operations, which very often our customers did not like. So the purpose of our approach is to show the shift that took place in that sense. We see that the world today is far more connected. The quality of the internet service is far better. As a result, we now have new services thanks to this development, while at the same time the requirements of our customers have also increased. This is because the enterprises now wish to have greater speed, more control, and many more things. But we also have issues related to the network itself. So it is in that context that we started to see the advent of SD-WAN, the software-defined WAN. The networks through these technologies can use an already existing infrastructure that we also offered previously. However, we now managed to provide far more flexible and smart connectivity to our customers. In the next slide, I will precisely be showing that. I want to share with you a case study on how we can build this new type of network, and based on that new network, we can also obtain and offer this new type of service to the users.
to that aim, let me go back to our example. We had the matrix connected to the several branches, but the role of the provider was only in providing the service. But now we skip something. We this is a new leap. We have more participation with the client. We have a more active engagement, as we are going to show you now. The first step for that next hop is, for instance, changing the machines or adding new machines. We are going to add where in the past we had the border provider. Now we are going to have something in the middle, midway. It's what we call SD-WAN edge. SD-WAN edge will be the machine responsible for building the backbone of CD-WAN. So we are SD-WAN. We're going to have a new leap because we see that provider edge were different. The difference that we have at present is that we are adding a third element in our story that will make a big difference, a huge difference from now on. So after increasing this SD-WAN edge, we started talking about approaches that very often are not very comfortable for, because the providers are not used to it. They have a different concept of the network. So first of all, what would be that network? The underlay for us? Well, it's a sort of the physical layer. You have the states, the machines, everything that is represented in this topology. We have MPLS, but we also have the internet circuit. So where is the change compared to the traditional model? Well, the first change is that it no longer interferes in these circuits. You have the responsibility with the provider, but we are going to have the final result for the client that is going to be the same. In the provision of services, for instance, SD-WAN, we are going to take the state that the providers used, the primary connectivity service, and we are going to and services like Starlink or 5G. And as in the past we had that infrastructure that was ready, now we're going to start with a small difference as compared to what we had in the past in our traditional infrastructure. So we're going to the model NSD1, and we are going to call it from the network overlay. We went from underlay to overlay. So we are going to establish VPN connections between the different branches of the matrix, from the matrix to the branches, so that our topology will ease the operations in our environment. You may realize that they no longer interfere. What we have, the creation of the dynamic environment through the CPNs, make it possible to isolate the underlay, the lower layer. And with the configuration that we have here, we're going to start talking about what the provider knows to do better. So in the past, we had the connection with providers, a routing connection, and this connection now, we're going to see what we could abstract. We can use a simpler model, an easier model for routing, but also with a configuration as CPP or BGP. So everything that we do here is through BGP. and we configure it through the VPNs. It's no longer the way it used to work in the past. And there's another very interesting thing that we need to mention, and it is that in this case, we are no longer going to use this for the decision making process for sending packets. When we speak of BGS1, the routing here will have more the role of informing all the paths available for that packet. So we established VPNs over those networks. We created the BGP clients, and BGP now will be used for the SD-WAN prefixes. This is the example that we can show. The branch 04 with MPLS sends the local prefixes to the matrix, and the matrix sends the prefixes to the other. They communicate the prefixes to the other branches, where we had to create a routing policy, and that was our key link, the link that we had to connect, and so on. So this approach of CD1, the routing, is given in an equal manner. All the attributes of the routing policy are distributed in the same manner, and all of them follow the same path, just the same, so that all of them may get installed in an equal manner in all the local areas. And that's very different from what we had in the past for routing. And why do we do this? Because the intelligence of traffic routing will no longer be based on routing. Routing will depend on connection, and routing will be done with the intelligence of SD-WAN that will define where the routes should, what path the routes should take. So with this routing, we're ready. Well, finally, we can build our SD-WAN tree. And now we can define, we no longer have to worry about the routing policies, but we only have to care of how the packets are going to be forwarded, and we have to we no longer have to worry about the health of the packet, the jitter, the and all the elements that are connected to that. So SD-WAN will give us much better quality, and we're going to be able to focus on more important things so that we can facilitate traffic. So, for it, just as an example, let me show you a communication that would leave from here, from where I'm showing, to the servers that are there. Our policy for creating statistics of the link, and we see that that link, the link that is healthier, is the one that SD-WAN will pick to do that routing. There's no need for us to limit ourselves to the to this. We can expand the example for the external connections, public connections, and so we do this again, the traffic that in the internet. So we are directing the flow via internet, the local internet in our branch, but depending on the size of the packets or the latency, and it might not be as healthy. The path may not be as healthy to follow that path, and SD-WAN will detect that, and automatically it will forward the flow, redirecting it through the path that in its view is in better conditions for that routing. So that is very important. That is, in the past, we needed a professional to analyze what was going on, and only then could we decide the new routing. But with this, we can do it automatically, and we don't need to interrupt any services or study the whole situation. We can even go beyond, because very often that SD-WAN is more associated to an issue of connectivity, which is not a wrong thing, because the focus of SD-WAN is connectivity. However, we can also consider other quality elements that are connected to SD-WAN, and that is, for instance, the centralized management. Now, I no longer need to see how each machine is doing, because if I have SD-WAN, I have a centralized control. That is, there's an entity that is in charge of that. The entity is called controller, and the not only does it control, but it does the maintenance of the machine. So we have a greater scalability, and as a consequence, we also have a dramatic change in the quality of the services that we provide. So in order for us to have these configurations, well, it makes life much more simple. And to bring nicer examples and as a summary of my talk, here I brought the benefits that SD-WAN offers as compared to the traditional model. So, as a summary, you see here these 4 things. The issue of scalability that we had mentioned earlier. You can enlarge the network. The issue of the automated links. As the example that I told you, where it would pick a different route, the centralized management and cost reduction. And the 4th item is the best of all, and it is that we are going to render services with added value. So very often, we wanted to provide simple circuits in the internet, and we managed to add all the packet of the services in a single product instead of standalone services. So we are providing the clients a service that is as much better quality, and this will in the end be a much better service. So that is the end of my presentation. I hope that you liked it, and once again, thank you for paying attention and for inviting me to talk to you today. Thank you, Matteo. Well, you used your 20 minutes. Thank you, Mateos. 20 minutes exactly.
En la sala o en el chat.
Your questions here, the chat for Mateos.
Bueno. Se fue. Okay.
Oh, he's gone. Okay, thank you. There you are. Thank you very much, Mateos. We will now go on to the next speaker. This is Fred Manuel Linares.